Hello guys, you are welcome to our mathematics and physics class. In today's video, we'll be dealing with heat transfer. So heat transfer is just like how we transfer heat from one body to another body, from cooler body to hotter body, or from hotter body to a colder body. So how we transfer it from one body to another. Now we have different method of transferring heat. So we can transfer by conduction, we can transfer by convection, and also radiation. So we will be dealing with these three. This conduction mostly occur in solid. So this one, convection, always occur in liquid. So now, and for radiation, this radiation is an electromagnetic nature of heat. So it does not require material medium for transmission of heat. So now, without wasting time, let's go straight to the calculation aspect. So for conduction, we have what we call Fourier's law of conduction. The Fourier's law of conduction states that the rate of heat, that is change in heat per unit time, is directly proportional to the area and the temperature gradient. So this temperature gradient this area and this rate of heat transfer. So introducing a constant, we have change in Q or T equal to K A change over T over N. So this constant is called thermal conductivity. So this L can refer to the length or the thickness of the material, and T is the temperature. The second T here is the time, and this heat. So the rate of heat is Q over T, and this is our area. So when the body is like spherical or circular, so the area will be area of the sphere, area of the circle. That's pi r squared or 4 pi r squared. So now let's solve one example. Now here is the example. So the first thing, we write out the parameter. Determine the quantity of heat we are asked to find Q. Okay. Which is conducted in 30 minutes. Time is 30 minutes, which is supposed to be in seconds. That is 30 times 16 seconds. Right? So of iron plate 2 centimeter tip. Okay, M 2 centimeter is supposed to be meter 2 times 10 raised to minus 2 meter, and this should be square. So 0.1 meter square in area. Okay, area 0.1 meter square. Okay, if the temperature of the two sides are 0 degree and 20 degree, and we theta 2 minus theta 1, you got 20 minus 0. That is the final minus initial. The coefficient of thermal conductivity, that is K, is 50.4. So I'm asked to find Q. So now the formula and formula is change in Q over T equal K A change in T over N. since we are looking for change in Q only, so we just have to cross multiply and make this solve formula. So change in Q will be what? K A change in T over L times T, right? So now our K is what? 50.4 times our area is 0.1. Our change in T is what? 20. Then our time is what? 3 times 60, that's 1800 seconds. So all over what? The thickness is what? 2 times 10 raised to power minus 2. So now let's calculate this using our calculator. So using calculator, the answer is 907,200 joule. 907,200 joule, because we are asked to find Q, and Q is what? Heat energy. So it will be in joule. So also you can be asked to find thermal conductivity and they will give you other value. You can use this formula to just make the thermal conductivity subject formula. You can be asked to find anything here and they will give you other value. So just know how to write the parameters. So now the next aspect we'll be dealing with is convection. Convection mostly occur in what? It only occurs in what? Liquid. So now under this convection, we have what we call Newton's law of cooling. We have this the formula, Newton's law of cooling. This is the equation. So now this T represents what? Temperature of object with time, that is with a specific time. TE can also be what? TS, that is temperature of environment or surrounding. T0, that is initial temperature. This E here is what? Exponential, that is what? Like log E is what? In, like this. So we apply log within there too. K here is decay constant. Time taken, this is the time taken for the cooling process. So now let's solve question for that. So a student heated water in a kettle to temperature of what? 80 degrees Celsius. Okay, fine. Let's say this initial temperature 80 degrees. So note that all the temperature in this Newton's law of cooling must be in what? Kelvin plus 273. Okay, then and the room temperature is this, that is temperature of the environment is what? 27, then plus 273. Okay, after 10 minutes the temperature is 50. That means the temperature with time is what? 50 plus what? 273. So this is how you write it down. And what? After 10 minutes the time there is what? 10 minutes, that is what? 600 seconds, that is 10 times 60. So write the equation of cooling of water. That is, we are asked to write in form of this, but in putting this value or inserting these values. So now let's go. The first question, the answer to number 1 is just like follow this thing. 80 plus 273, that's the initial temperature, that's 350. Let's first write it out. This is 353. This plus this, we have what? 300, and this plus this, 50 plus 273, which is 308. Now let's insert these values. Now we have a TT, that is 308, equal TE, that is 300, plus into bracket T0, that is initial, that's 350, minus what? TE 300, then exponential minus what? T is what? 600, then 9K. So this is the equation. this general equation. That is the answer. So now the next thing is how long will it take for the water to reach 35 degree? That is when the temperature is at 35, what will be the time? But all these things will still remain the same. Or what will be the time if the temperature changes to 35? That's what we are asked. So but before we can do that, we have to get our decay constant first. So how do we get that? So 308, this one comes to this place. I have a 308 minus 300 is 8. Then 353 minus this, I have a 53 exponential minus 600k. Then I divide by 7 almost 53. So now my exponential 600k will now be what? So to remove this exponential, it is the logarithm to base e. So taking the logarithm of also. So this one will now be what? Natural logarithm of what? 8 over what? 53. Right? So introducing this here, and let me first leave it like this. So now it will now be minus 600k. So to eliminate this, you introduce a natural logarithm here. 8 over 53. Now minus 600k is what? So this pressing this into the calculator. So then so it should give us 0. Should give us minus 0.834 minus 0.834 minus 0.8349. So dividing both sides by minus 600. So our k will now be what? K will now be 0.00139. So these are our decay constants. Now since we've gotten our decay constant, we now come back to this, changing this 50 to 35. So now the next thing is that what our new T, that is what temperature with given time, will now be what? 35 plus what? 273. So 35 plus 273 will give me 308. Wow. 35 plus 273, 308. I think I'm ready. So this 323 and this what? 23. Yes, that's the mistake. Now this should be what? 23. Now that's it. Now the new T will now be what? 308. So inserting 308 here, we now have 308. It will now be equal to what? 300 plus what? 353 will still remain the same, minus what? 300 raised by what? Exponential raised by minus what? It will not be minus 600 again because we are looking for the time. So it will now be what? Minus kt. So inserting our value of k here, so now to get our answer. So what is the next thing? Collecting like this one will now have what? 8. Then will now be what? Equals what? This minus 0, I have what? 53 exponential what? My k minus what? 0.00139. Then dividing by 7 over 53. Now then my t will be here, and I have what? Exponential minus 0.00139 t equals this 8 over what? 53. So taking the logarithm, and I have what? Minus 0.00139 t is now equal to what? Then is 8 over 53. So minus 0.001390 will now be equal to what? Pressing this into your calculator, 8 over 53, you have minus 1.8908. So dividing both sides by this, minus 0.00139, minus 0.00139. So now our t will now be what? That's what? Minus 1.89009 divided by minus 0.00139. So I have what? 1359.7. So it is time, it will not be what? Seconds. So that is the final answer, and you can round it up to this. So now that's the final answer. So the next one we'll be moving to is radiation. Now we will be dealing with we'll be moving to the last aspect of this video, which is what? Radiation. So radiation is what? Electromagnetic in nature and does not require material nature. So we now have something we call black body. So any black body, any ideal black body absorb all radiant energy. So just note that, and any white body reflects all radiant energy. Now anybody with temperature absolute 0 radiates what and absorb what? Radiant energy. Now let's move to emissive power. So absorptive power is the ratio of amount of heat absorbed to the ratio of amount of heat incident. So that is ratio of heat absorbed or what? Ratio of what? Heat incident or what? Heat reflected. So emissive power is the ratio of amount of heat emitted to what? To the what? Ratio of to heat radiated. Now we have what we call emissivity of black body. So emissivity of black body, emissivity is always like this for black body. It is 1. So emissivity ranges from 0 to 1. So it can be 0.10 to 0.10. So it ranges from 0.1. So the highest is 1 and the minimum is 0. Now emissivity of the black body is what? 1. So any body like, so if a body has what? Emissivity like 1, so it is a what? Good emitter. For emissivity is equals to 0, so for emitter. Also we have the same thing for what? Absorption. Emissivity of what? Absorption is what? Of black body is what? 1. And if emissivity, no, this is not for black body, this is for black body. Black body emissivity is what? 1. And what? Absorptive power. Let's replace that power. Absorptive power of black body is 1. So it is what? Good. So this is a good absorber. When emissivity, when absorptive power is equal to 0, it is what? Poor absorber. So now we now have reversed law. So we have this is power emitted is equal to what? Emissivity, then this area into like what? T raised to power 4 minus what? T e raised to power 4. As you all know that what this T is what? Temperature of environment, and the T here is what? Temperature. The ordinary T is what? Absolute temperature. Our A is area. So when we are given a question and we are not given area, but in the question they gave us that what we are dealing with is about area of a circle, area of a sphere. So we use the formula for area of a circle and also the formula for area of a sphere, area of a sphere, depending on what they give us. And this one is what? Emissivity. So when they give us in the question like emissivity of a black body, just know that that is one, so you don't have to look for anything there. But when it is not a black body, they will give us, so, and this is power emitted. Now that is that. So same thing applies to absorption. P absorb is equal to what? For absorption, it is like the same thing. Let me just say, instead of this emissivity is what? Absorptive power, then this A, then T minus what? T e raised to power 4. This sign here is called Stephen Boltzmann constant. So it is a constant. When you see it in this radiation topic, it is what? 5.67 times 10 raised to power minus 8. So it is a constant, Stephen Boltzmann constant. So now let's solve question on radiation. So this question is spherical body at this, we are given temperature to the what? 200 degree plus what? 273, like that's what? 470. That's what? Joule per second is what? Power 50. Then assuming, so we have to find radius, but the formula is what? P emitted is what? Emissivity. I mean, since it is a dark body, so it will be what? 1. Then Stephen Boltzmann constant area into like what? T. I mean, so since we are not given temperature of the environment, so it will just be T raised to power 4 only. Now our area, know that area of the sphere is what? 4 pi r square. That's the area of the sphere. So inserting that here, so our P emitted now will still emissivity, then it will go to my constant 4 pi r square, right? Then T raised to power 4. Now we are asked to find R. So making R the survey from that, we now have square root of what? P. That is the divide both sides by what? This, then T raised to power 4. Then I take the square root to remove the square here. So that's just it. So inserting the value of P, this to get our final answer. So this is, so inserting this into your calculator, you get 0.0374, which is what? 3.7 times 10 raised to power minus 2. That since it is rated, it is meter. So that's that. So you can also be asked to find any other thing apart from what radius. You can be asked to find the power, and they will give you the meaning. So you can be asked to find the area. You can be asked to find the temperature given the area and this power. So you can be asked to find it. So just know the formula. Since we don't have temperature of environment, so we will not include it here. We assume it is 0. Now, when there is temperature of environment, so it will go up minus temperature of environment. That's that. So we have radiant emittance. Radiant emittance like this is what the formula is just like Stephen Boltzmann constant T raised to power 4. So this is, so they can just ask you, giving you in degree Celsius to find what the radiant emittant of what black body at this temperature and that temperature. So this is the formula they use. Thanks for watching. Please click on the subscribe button, share my videos with friends. Thank you. Please subscribe, like, and also comment.